moving on to the next presentation. So we have Jimmy Melskens, Senior Product Manager at AIKO Solar, who is going to talk about combining high reliability with superior aesthetics. So you can also guess from the title that he's also going to talk about, he is going to talk about the back contact cell technology and module technology from AIKO. So, Jimmy, the floor is yours.
Okay, thank you very much for the nice introduction. I'll share my screen. I hope my screen is visible.
Yes.
So we start. So this presentation will be about the AIKO product, and especially with a focus on the reliability. So we all know, I think, that it is a back contacted configuration and that there's nice aesthetics. So I would like to tell you a little bit more about those two aspects and a few more things as well. So first, an introduction on who is AIKO actually. For the people who are not familiar with AIKO, I will say a few things about that. And the best way to do that for me would be to show you a nice video. So that is what I will do. So I'll first let you enjoy this video and then we continue to the rest. Okay, so what you saw there was a nice overview of our production line. You can see that it is very automated. It is comprised of a back contact cell configuration. So it's the cell manufacturing process really. And to put it in numbers that you can see here, there has been a strong focus always on making cells, not modules so much. That is a more recent development. So the solar cell output already exceeds 100 gigawatts, revenue exceeding 5 billion. There's 3 global R&D bases and more than 17,000 people already. What is also special to mention is that there's a very strong emphasis on R&D work. If you want to achieve very high efficiencies, it's of course essential to keep on developing and pushing technology always. So that's why there's a strong focus on this, also visible in a number of patents filed. So then there's production capacity. 61 gigawatts is the current annual cell production capacity. This is all manufactured in different facilities in China with an R&D lab in Germany. The module capacity is 25 gigawatts already. And in the last year, there's been big expansion activities all over Europe. So the map of Europe is basically divided into different zones, as you can see here, and different people from the local countries have been found to establish and expand the market over there. For instance, myself, I'm working between the Dutch office in the Netherlands and the office in Düsseldorf in Germany. There's different people in the different regions. At the moment, we are with 60 people already in the EU, and the plan is to expand this to 110 people by the end of this year. So then some technological milestones. The foundation of AIKO was almost 15 years ago already. First focus on PERC technology aspects, then a move towards larger wafers, 210 millimeter wafers. Then the interdigitated back contact design, or the all back contact cell, as it is called internally at AIKO, was established and invented. Efficiency there very high with 26.5%, and then the step was made also to make it into modules, which achieve efficiencies of already 24%. And then the bigger ambition is to achieve carbon neutrality in different regions. For instance, there's a region in Austria where this is already targeted to happen in 2030, and that can be aided with very high efficient panels. So then, as I said already, there's of course the whole value chain. So if you want to do vertical integration all the way, you have to master a complete process flow from polysilicon all the way down to installations. So the focus of AIKO really, although there's also investments and stakes in the polysilicon work and the wafering work, the main focus is really on the cell manufacturing and the modules. And recently also this so-called one-stop solution has been added to the portfolio, meaning that there's a complete solution for your house that you can get, which is panels, an inverter, a battery, and basically everything that a modern house requires. But the emphasis, like I said, is on the cells and the modules. So let's talk a little bit more about this. What is then the AIKO ABC module? So ABC, I already mentioned it, is the all back contact cell. What is this really? Is it so new? Well, if we look at academic developments, we know that it has been going for some decades already. It was for a very long time in the research atmosphere, and only recently people begin to recognize that you can really do it industrially. I would say this is really the AIKO achievement, that you can commercialize this rather complicated cell design and really make a product that's commercially viable. So now this ABC module is basically on the market, has been recognized by different parties that you see on this slide here. Then basically, how does this work for the people who are not so familiar? So of course, back contact means that all the contacts are on the back side, so there's no bus bars on the front, meaning there's no shading losses, which is of course good. Of course, a good thing for your current generation. So the short circuit current density is improved by this, but it also means that the front side can be completely optimized for capturing the light, and also the surface preservation of the silicon on the front side is very strongly optimized. And this means that your recombination loss or the electrical recombination losses are strongly mitigated. And at the same time, you get this very black panel, which is aesthetically pleasing, of course. Then to summarize some key features of the ABC module, you can also express this in the numbers as you can see here. So one noteworthy aspect especially is the temperature coefficient. We see that it is really low. It's only minus 0.26% per degree C, with still high warranty. So for the performance, there's a warranty of 30 years provided. Then if you employ these panels instead of more conventional PERC type panels, you can see that your yield or your production of your system is significantly higher. You can see that it can be up to 15% more. And this is due not only to the higher power output of these modules compared to, let's say, competing products, but also because the degradation over time is less. So we see in the first year that we are below 1%, and the annual degradation after that year is only less than 0.35%. So that's also a small amount. Consequence also of having a high power output of your module is that you basically need less panels to fill the same area to reach the same system output. And it means that you can reduce the balance of system cost in this way. So cabling costs, for instance, they're also reduced. So again, this is also an aspect where you can save money. And the aesthetics, of course, I already mentioned that you see in this picture, the nice black panel. It is very attractive for building integration, also integration in landscapes in densely populated areas like the Netherlands is becoming very important to not disturb the landscape too much. And then these types of panels are also really attractive. So when we talk about reliability, of course, temperature coefficient is one aspect, and degradation over time. These are important matters, as well as the black front without the grid lines. Then we look at the portfolio of AIKO. You can see an overview here. So the residential scenario is shown on the left-hand side. There's different types of panels with a foil backside or a glass backside. So then we call it the dual glass module. For the residential market, we have a 54 cell module or 54 half cells really. Then for the CNI scenarios, we have somewhat larger panels. So the installation of large field is less laborious. You see, I can see here that the choice was made for 72 cell modules. And then for utility scenarios, we're also given. I'm going to look at this more. That also concerns installation with these large modules available in the single glass and dual glass. And also with a white backsheet for, let's say, more current generation, or a black backsheet for more aesthetic appearance. Then if we look again at the comparison in a bit more detail, you would like, of course, to optimize your yield per square meter area. So here we see the AIKO ABC panel compared to, let's say, a typical TOPCon module or a typical PERC module. And you can see that in basically all the parameters that are important, the AIKO module is better. So then we talk about the rated module power, the efficiency, temperature coefficient, and degradation over time. It all results in a higher power density, and eventually what matters for a customer is the lifetime production of your system. If you compare to the PERC, we are, let's say, 19% higher, and for the TOPCon comparison, it's a plus of 9%. So these are aspects, again, linked to reliability, of course. Then when we compare to other products, you see this table here from the Young, I think very familiar to this community. You can see that AIKO is there on top with 24%, and the difference with the other parties is quite significant. If you look at the gap between the others, the gaps are not so large, but then near the top, you can see there's quite some improvements. So this is the a result of pushing this technology with a back contacts, excellent service preservation, and strong investments in R&D for years. Then when we look at this temperature coefficient in a bit more detail, we see here a result coming back from certification test. We see that this 0.26% per degree C is indeed confirmed. This is the best result for back contact cells, actually. And when we put it to the test in real life, you can see on the right-hand side some installation in Doha, Qatar. And you can see that the lower temperature coefficient, of course, in this climate, temperatures are very high. There's higher radiance, not so many clouds. And then a low temperature coefficient is really important. And you can see, for instance, in this one day that you see here, that is already a 2.4% extra gain in watt peak output, only due to the better temperature coefficient when you compare the ABC module to a PERC module. Then when we look at some other aspects, of course, back contact cells have all the contacts on the backside, and that brings some other benefits as well. So for front back contacted cells, you have to contact, of course, every cell next to each other from the front to the back, meaning that there's a soldering process where you get some stressed metal lines. If you have all your contacts on the backside, this is not there. So you have all your metallization basically on the rear side, and that is attractive, of course, for, let's say, ease of production, but also for robustness. So if we talk about reliability again here, suppose your panel is bending a little bit because of mechanical deformation due to strong winds or snowfall. It's important also that the metallization inside the module does not get damaged or break. And that is much less likely to happen if you have such soldering only on the backside. So actually it's 3 times as strong as a traditional technology. Further aided also by the fact that we have a lot of bus bars on the backside, 20 in fact. And this also reduces the resistive losses, so the charge carriers that are generated that need to reach the metallization. This is mitigated, so for performance that's very good, but also for reliability. Actually, the chance of getting micro cracks in your product in this way is also reduced. Then when we look in a bit more detail, some results from reliability testing. So there's different tests that are defined for typical ISC norms, for instance. So then we talk about DAMP testing, thermal cycling, potential-induced degradation, and light-induced degradation. Without going to the details of everything, you can see here in the bottom graph that the PERC module is really beaten by by the AIKO product in all cases, and the consequence is that over time, so over the lifetime, that's the graph that we see on the top left, that the performance reduction is much less pronounced. So we see that over the course of 30 years, still 89% of the performance is retained, which is about 7 or 8% higher than the PERC competing product. So then also AIKO received recently the so-called Red Dot Award. And this has to do with how the appearance our product. So you see that in this particular case, with a rather black-looking roof tile configuration on this building, you can see that the panels really blend in well. Then we talk about reliability aspects of the ABC module a bit more. We see that key reliability features of our ABC module. So then we talk about material usage. This is due to the fact that we use high quality N-type wafers. They have very low defect density. Then we also make use of strongly passivating contacts based on polysilicon, and there's also the complete avoidance of front-side silver metallization thanks to the interdigitated back contact cell design. Then on the back side, we have some options. So let's say the more conventional route is with foil. We also have a glass rear side, and this ensures an extra lifetime. So the performance warranty, then we are at 30 years. This is due to a low temperature coefficient and a limited long-term degradation. And also the shaded performance of our product is very good. So if you talk about hotspot formation, this is of course really bad in all panels. In our case, the temperature of the product and also potential hotspots that are being formed is significantly lower. So then we see a 50-degree difference actually of the hotspot itself when we compare to a more traditional product. And then there's also the anti-cracking robust design. So that is linked to the fact that we have all the connections on the back side and soldering stays on the back. Basically, there's no front to back soldering connections. So then that is all reliability aspects. And then if you want to exploit the performance that we have, so the high efficiency and also the reliability aspects, of course, for a real life application, you're very interested in the earnings. So here, just one typical example. This is a house in the Netherlands that you see here. So if we compare the ABC rooftop installation to a PERC installation, you see that initially you spend a little bit more money, but after about 3 years, your investment is already earned back. And then for the remaining 27 years, if you consider a 30-year lifetime, you see that you can actually reach a net profit in earnings that is 21% higher for the AIKO system compared to a competing PERC product. So the initial price that you pay is a little higher, but it is paid back very quickly, and then you enjoy some extra revenue for many years to come. And with that, I would like to show you actually the last slide. So that is the outlook. So AIKO is always pushing on R&D, like I already said a few times. That is translated to these kind of products. So you see that for the, let's say, the smaller 54 cell module and the largest 72 cell module, there are current activities ongoing to push up the power output of these modules. So these are the products projected to be released over the course of next year. Then we also get a bifacial module and a lightweight module, which weighs about half of the other ones. And that is attractive for rooftops that can carry less weight, for instance. It's also easier to install. And so it should also reduce the balance of system costs even more. And with that, I would like to thank you for your attention. And I'm happy to take any questions from your side.
Great. Thanks, Jimmy. It was a nice presentation. So it is really interesting that even AIKO is planning to come up with a bifacial module with back contact cell architecture. So can you say something about the bifaciality? How much it is going to be? Is it going to be less or better than PERC? Do you have any idea?
Well, to be honest, the bifaciality is a little bit less than compared to a PERC module, because for a PERC module, you can also optimize very strongly on the back. That is also what you need to do there to still gain efficiency, because there's nothing left almost where you can improve. But for the IBC cells, it is much more important to do front-side optimization. So there is some bifaciality there. I don't think I can disclose yet what the numbers are, but it is a bit more modest than the PERC product. Having said this, you should look at the earnings, let's say the yield over a year. You will see that the IBC layout, if it's an AIKO product or not, it will be superior to that.
Okay.
So the bifaciality is modest, but not the key decisive factor, I would say, in the earnings. If you have a very strongly passivated front side and a good, a very good anti-reflection coating that already pushes up the efficiency a lot.
Yeah, so so the bifacial, is it going to be glass, or do you have any projects that are running also with the transparent backsheet? So
I think the aim is to go for glass because this is also already in the portfolio at the moment.
okay, thank you very much, Jimmy. That
You're
was
welcome.
a great presentation. And
You're
please
welcome.
stay online. And if there are any questions in the chat window, please try to answer these questions. Great. Thank you.
Yeah, you're welcome.